Wyoming Territory, late autumn. A rancher stares at his collapsed barn door. The hinges just gave out. Winter storms are 3 days away, and the nearest hardware store is a week's ride. His cattle will freeze without shelter. But here's the thing most people don't know about the Old West in 1879. The real problem wasn't the broken hinge. The real problem was that buying a replacement was nearly impossible, because across thousands of miles of frontier, ranchers couldn't get nails, hinges, or basic metal fittings. So they forged every single piece themselves from scrap metal. And this wasn't rare. It was how the West was actually built. Picture the American frontier in 1879. The Industrial Revolution was transforming eastern cities into manufacturing powerhouses. Factories in Boston, New York, and Philadelphia were mass-producing hardware by the ton. Steam-powered machines stamped out nails by the thousands. Foundries cast hinges in standardized sizes. The modern world was arriving, but only if you lived near a railroad depot or a major city. For the ranchers scattered across Wyoming Territory, Montana, the Dakotas, and the vast stretches of open range in Texas and New Mexico, that modern world might as well have been on another planet. The geography alone made supply chains nearly impossible. A ranch in central Wyoming could be 80 miles from the nearest town, which itself might be another 100 miles from a railroad depot. Even when the Transcontinental Railroad was completed in 1869, the rails only connected major points. Spur lines were expensive to build and slow to extend into remote areas. By 1879, railroads had reached more territory than ever before, but the vast majority of working ranchers remained days or weeks away from any depot. Transportation costs made small hardware economically absurd. A freight wagon traveling from a rail depot to a remote ranch charged by weight and distance. Shipping a 50-pound crate of nails over 100 miles of rough terrain could cost more than the nails themselves were worth in Boston, and that assumed the freight company was even willing to make the trip. Most wagon freight focused on bulk goods: flour, sugar, tools, lumber, items that justified the journey. A rancher who needed 3 hinges and a pound of nails couldn't economically order them. The shipping would cost 10 times the product value. Even when ranchers made it to the nearest general store or hardware supplier, selection was limited. Store owners stocked what sold in volume and what could survive long storage. Nails, yes, but only common sizes. Hinges, maybe, but only standard patterns. Specialized fittings, custom brackets, unusual sizes. Forget it. And prices reflected the supply chain. A pound of cut nails that cost 8 cents in Philadelphia might sell for 50 cents in a frontier town. For a rancher building a barn or repairing corrals, the cost added up fast. Buying enough nails and hardware for a single large project could consume a significant portion of annual cash income. But the real issue wasn't just cost or distance. It was the nature of frontier economics itself. Ranches operated on thin margins. Most income came once or twice a year, after cattle drives or wool sales. Cash was scarce, credit was limited, and hardware stores in small towns often ran out of stock. When a shipment of nails sold out, it might be months before the next freight wagon arrived with more. Ranchers couldn't wait months for a broken gate latch or a snapped hinge pin. Cattle needed to be managed now. Fences needed to be repaired before the next storm. Barns needed to be secured before winter. So, ranchers adapted. They saved every piece of scrap metal that crossed their path. Broken wagon parts became raw material. Worn-out tools were stockpiled. Bent horseshoes, snapped chains, cracked barrel hoops. Anything iron or steel went into the scrap pile. And when something broke, when a hinge failed or a gate needed a new latch, the rancher didn't ride a week to town. He walked to the scrap pile, fired up the forge, and made what he needed. The scrap metal economy of the frontier was a closed-loop system born of necessity. Every ranch had a scrap pile, usually near the barn or workshop. It was as essential as the water trough or the hay barn. Cowboys, riding the range, kept an eye out for metal. A broken plow blade abandoned by a passing homesteader. A section of chain left behind by a freight wagon. Anything metal had value because it could be transformed. Railroad expansion created an unexpected windfall as rail lines pushed west through the 1870s. Maintenance crews left behind a trail of useful scrap. Bent railroad spikes were everywhere. Each mile of track required hundreds of spikes to secure the rails to the wooden ties. Over time, spikes bent, broke, or were replaced during maintenance. Crews tossed the damaged ones aside. For cowboys, these were treasure. Railroad spikes were made of high-quality wrought iron, tough, consistent, and easy to work. A pile of bent spikes could be converted into dozens of nails, hooks, gate pins, and small brackets. Rail plates, the metal plates that sat between rails and ties, also ended up in scrap piles. When worn or cracked, they were replaced and discarded. These plates were flat, thick, and made of good steel. A rancher could cut them into straps for hinges or brackets for reinforcing joints. Chains used in rail construction, heavy and durable, could be cut apart and the links forged into hooks, handles, or fasteners. Even broken tools left by railroad work gangs, hammers with snapped handles, pry bars with bent ends, found their way to ranch forges. Wagon parts were another primary source. Freight wagons and ranch wagons took brutal punishment on rough frontier roads. Axles cracked, wheel rims bent, tongue hardware broke, hitch components failed. When a wagon was beyond repair, it was cannibalized. The metal parts, axle ends, rim sections, bolts, brackets were saved. Wheel rims, in particular, were valuable. They were long strips of iron, already curved, perfect for cutting and shaping into hinges or reinforcing bands. Worn-out tools provided smaller but useful scrap. A shovel with a cracked blade could be cut up for small brackets or shims. A broken pickaxe head could be reforged into wedges or punches. Old saw blades, too worn to cut wood effectively, could be shaped into knives, scrapers, or small chisels. Every piece had potential. The quality of scrap mattered. Not all metal was equal. Cast iron, used in stove parts and some machinery, was brittle and difficult to forge. It could be melted and recast, but that required equipment most ranchers didn't have. Wrought iron, the most common material in the 19th century, was ideal. It was malleable when heated, easy to sharpen, and could be forged welded to join pieces. Steel, less common but increasingly available, was harder and held an edge better, useful for tools and cutting implements. Cowboys developed practical methods for identifying metal types. The spark test was common. Grinding a piece of metal on a spinning stone produced sparks. Wrought iron threw long, straight, yellowish sparks. Steel produced shorter, whiter, more explosive sparks. Cast iron barely sparked at all. The file test was another method. A file would bite into wrought iron easily, skip across hardened steel, and crumble cast iron. These weren't scientific tests, but they worked well enough for frontier needs. The value system around scrap was informal but real. A pile of railroad spikes was worth more than an equivalent weight of barrel hoops. Wagon axle iron was prized. Broken chains were valuable. Ranchers traded scrap between neighbors. A cowboy might ride 10 miles to retrieve a broken plow blade someone mentioned seeing. Hoarding wasn't greed. It was survival strategy. You never knew when you'd need to forge something critical, and having the right scrap on hand could mean the difference between a quick repair and a week-long problem. But scrap metal was useless without the knowledge to work it, and that's where the real frontier skill came in. Blacksmithing wasn't exotic knowledge. In the 19th century, it was common, practical, and widespread. Most men who grew up in rural areas had at least basic familiarity with forge work. Some had formal apprenticeships. Others learned from family members. Many picked it up out of necessity, watching, trying, failing, and eventually succeeding. Skill levels varied widely. A few ranchers had cowboys who were trained blacksmiths, men who had worked in shops before heading west. These individuals could do fine work, precise joinery, clean welds, properly tempered tools. Most cowboys, though, were competent amateurs. They could heat metal, hammer it into rough shapes, and make functional if crude fittings. And some were desperate beginners, learning by trial and error because there was no other option. The knowledge base came from multiple sources. Former soldiers, especially those who had served in the Civil War, often had experience with field repairs and improvised metalwork. Military units had traveling blacksmiths, and soldiers learned by necessity. Immigrants from Europe, particularly from Germany, Ireland, and Scandinavia, often brought blacksmithing traditions with them. In rural European communities, forge work was a standard skill. Even men who hadn't been professional smiths often knew the basics. The forge itself could be simple or elaborate, depending on the ranch's resources. A permanent ranch forge was usually a brick or stone structure, waist-high, with a fire pit in the center and a hand-cranked or foot-operated bellows to force air into the coals. The increased airflow raised the temperature high enough to make iron malleable. A proper anvil, a 100-pound block of hardened steel with a flat face and a pointed horn, was the ideal work surface. But anvils were expensive and heavy to transport. Many ranchers improvised. A section of railroad rail, stood on end and partially buried in the ground, made a serviceable anvil. The flat top of the rail provided a striking surface. It wasn't as versatile as a real anvil, but it worked. Large, flat rocks could serve in a pinch, though they cracked under repeated hammering. Some ranchers used buried iron blocks, chunks of scrap iron set into the ground to provide mass and stability. Portable forges were common for remote line camps or during cattle drives. A shallow pit dug in the ground, lined with rocks, served as the fire pit. A hand-cranked blower, a simple wooden box with a fan inside, forced air through a pipe into the coals. This setup could be assembled in an hour and disassembled just as quickly. It wasn't efficient, but it allowed emergency repairs far from the main ranch. Fuel was a constant concern. Coal, the best forge fuel, burned hot and clean, but coal was expensive and hard to get in many areas. Ranches near rail lines could sometimes buy coal from the railroad, but it was costly. Charcoal, made by slowly burning hardwood in a low-oxygen environment, was a common alternative. It burned hotter than regular wood and produced less smoke. Making charcoal was labor-intensive, but it was doable. Hardwood, oak, hickory, mesquite was stacked in a pit covered with earth and burned slowly for days. The result was lightweight, carbon-rich fuel perfect for forge work. In areas without good hardwood, ranchers burned whatever they had. Softwood like pine burned too fast and too cool, but it could work for light tasks. Some ranchers used dried buffalo chips, the dung of the vast herds that once roamed the plains. By 1879, the buffalo were nearly gone, but dried chips were still available in some areas. They burned hot enough for basic forge work, though the smell was unpleasant. Temperature control was critical. Too hot, and the metal burned, becoming brittle and unusable. Too cold, and it wouldn't move under the hammer. Blacksmiths judged temperature by color. Black or dark red, around 900 degrees Fahrenheit, was too cold for most work. Bright red, around 1300 degrees, was good for bending and light shaping. Orange, around 1500 degrees, was ideal for heavy forging. Yellow, around 1800 degrees, was hot enough for welding. White heat, above 2000 degrees, was dangerously close to burning. Experienced smiths read these colors instinctively. Beginners learned by ruining a few pieces of scrap. The tools were simple but essential. A hammer, preferably a crossbeam or ball-peen design, was the primary shaping tool. Tongs held hot metal safely. Punches made holes. Chisels cut metal. A hardy, a chisel that fit into a hole in the anvil, allowed cutting without dulling the anvil face. Many of these tools could be improvised or made from scrap, but a good hammer was worth its weight in gold. Making nails from railroad spikes was one of the most common tasks. A railroad spike was about 6 inches long, square in cross-section, with a flat head. To convert it into nails, the smith heated the spike to orange heat, then hammered the point end on the anvil, drawing it out into a thinner, sharper point. The process, called drawing out, stretched the metal by hammering it while moving it across the anvil. Once the point was formed, the smith used a hardy to cut the nail to the desired length. The cut end became the head. A few quick hammer blows on a nail header, a small tool with a depression, flattened and shaped the head. The whole process took 2 to 3 minutes per nail for an experienced smith. A pile of 50 bent spikes could yield 100 usable nails in an afternoon. Hinges were more complex. A simple strap hinge required a flat piece of metal, a hole for the mounting screw or nail, and a knuckle to hold the pin. Starting with a piece of scrap plate, perhaps cut from a wagon rim or a rail plate, the smith heated it and hammered it flat and smooth. Punching, the mounting holes required a punch and a lot of force. The smith placed the hot metal on the anvil, positioned the punch, and struck it with the hammer until it pierced through. The knuckle, the cylindrical part that holds the pin, was formed by bending one end of the strap around a rod. This required precise heating and careful hammering to avoid cracking the metal. The pin itself was a separate piece, usually a nail or a length of rod, that slid through the aligned knuckles of 2 hinge straps. Forge welding, joining 2 pieces of metal without modern welding equipment, was an essential skill. The process relied on heating both pieces to yellow or white heat, applying flux to prevent oxidation, and hammering them together. Flux, usually borax, sand, or clay, melted and formed a protective layer that kept oxygen away from the hot metal. Without flux, the metal oxidized and wouldn't bond. The smith heated both pieces, sprinkled flux on the joint, and placed them back in the fire. When both reached welding temperature, he quickly placed them on the anvil and hammered them together with rapid, overlapping blows. Done correctly, the 2 pieces fused into one. Done poorly, the joint was weak and would fail under stress. Mistakes were common, especially for less experienced smiths. Overheating was a frequent problem. Metal heated past white turned sparkly and began to burn. Burned metal was ruined, crumbly and weak. It had to be discarded. Cold working, trying to shape metal that wasn't hot enough, caused cracks. Wrought iron was forgiving, but steel could shatter if hammered cold. Poor welds were another issue. A joint that looked solid might fail under load, especially if the flux hadn't been applied correctly or the temperature wasn't high enough. Quality varied based on urgency. An emergency repair, done quickly to get a gate working again, might be crude but functional. Planned work, done with time and care, could be surprisingly refined. Over time, even amateur smiths improved. Repetition built skill. A cowboy who forged his first hinge in an hour might do his 10th in 20 minutes, with better results. The Wyoming rancher with the collapsed barn door faced exactly this challenge. His hinges, hand-forged 5 years earlier, had finally worn out. The pinholes had elongated from constant use. The straps had cracked from repeated stress. Winter was coming. He couldn't wait. He walked to the scrap pile and found a section of wagon wheel rim, a curved iron strap about 3 feet long and 2 inches wide. It was rusty but solid. He also grabbed 2 bent railroad spikes for pins. He fired up the forge, using charcoal he'd made the previous month. The bellows wheezed as he cranked the handle, forcing air into the coals. The fire brightened from red to orange. He placed the wagon rim section into the fire and waited. When it glowed orange, he pulled it out with tongs and laid it on his anvil, a section of railroad rail. He hammered it flat, smoothing out the curve. Sparks flew with each strike. The metal gradually straightened. He cut the strap into 2 pieces with a chisel, each about 14 inches long. Back into the fire. Heat, hammer. He punched holes for the mounting nails, 3 holes per strap. The punch was a sharpened bolt. Each hole took a dozen heavy blows. He formed the knuckles by heating one end of each strap and bending it around a rod, creating a cylinder. The 2 knuckles had to align perfectly, or the pin wouldn't slide through. The pins were easier. He heated the railroad spikes, hammered off the heads, and shaped the shanks into smooth rods. He cut them to length. The whole process took about 3 hours. The hinges weren't beautiful. The straps were slightly uneven. The knuckles weren't perfectly round, but they were strong. He mounted them on the barn door with hand-forged nails. The door swung smoothly. It would hold through the winter, and it did for another 5 years. This scene played out thousands of times across the frontier. A corral gate latch broke during spring branding season in Texas. 200 head of cattle were penned. waiting to be branded. The gate had to stay closed. A cowboy grabbed a broken shovel blade from the scrap pile, heated it in a ground forge fueled by mesquite wood, and hammered it into a new latch. The work was rough. The latch was ugly, but it held the gate closed for 3 full seasons before needing replacement. A freight wagon broke an axle bracket 100 miles from the nearest town during a cattle drive in Montana. The bracket, a U-shaped piece of iron that held the axle to the wagon frame, had cracked from constant jolting. Without it, the wagon couldn't move. The drive couldn't stop for a week while someone rode to town. A cowboy who'd learned basic smithing from his father set up a portable forge. He used spare horseshoes and broken chain links as raw material. He heated them in a fire pit, hammered them into rough shapes, and forge welded them together. The repair wasn't pretty, and it wouldn't last forever, but it held for the rest of the drive. Once they reached the ranch, a proper replacement was made. In Montana Territory, a rancher spent 2 weeks in the fall of 1879 preparing for winter. He inventoried every building, every gate, every piece of equipment. He made a list of needings: 12 hinges, 20, 50 hooks for hanging tools and tack, 30 brackets for reinforcing joints, 100 nails of various sizes. He could have tried to order them, but the cost would have been prohibitive and delivery uncertain. Instead, he spent the 2 weeks at the forge. He worked through his scrap pile systematically. Wagon parts became hinges. Railroad spikes became nails. Broken tools became brackets. He worked 10 hours a day, heating, hammering, shaping. By the end, he had everything on his list. The quality varied, but every piece was functional. When winter storms hit, his buildings held. His gates worked. His equipment stayed organized. He'd forged his way through the season. Railroad spikes were so valuable that cowboys celebrated finding them. A maintenance crew working on a section of track near a ranch in Wyoming left behind a pile of bent and broken spikes, perhaps 200 in total. Word spread among the nearby ranchers. Cowboys rode over and filled saddlebags. One rancher later said that pile of spikes provided hardware for his ranch for 2 full years. Himaji, nails, hooks, gate pins, and small tools. The iron was consistent and high quality. It forged easily and held up well. Finding that pile felt like striking gold. The cultural impact of this necessity-driven metalworking was significant. Self-sufficiency wasn't just a value, it was survival. A rancher who could forge his own fittings didn't depend on distant supply chains. He controlled his own infrastructure. This bred a deep pride. Men took satisfaction in solving problems with their own hands. A well-made hinge or a sturdy latch represented skill, resourcefulness, and independence. The forge became a social center. When neighbors visited, they often spent time at the forge, sharing techniques, trading scrap, and discussing solutions to common problems. A rancher who figured out a better way to make a gate latch would demonstrate it. Others would adopt the technique. Knowledge spread through informal networks. There were no instruction manuals, no formal schools. Learning happened through observation, conversation, and experimentation. Women participated too, though less commonly. Some ranch women learned basic forge work out of necessity. When men were away on cattle drives or working distant line camps, women managed the ranch. If a hinge broke, waiting weeks for a man to return wasn't practical. Some women became skilled smiths. Others handled simpler tasks, making nails or shaping hooks, while leaving complex work for later. The economic logic was straightforward. Forging a hinge from scrap cost only time and fuel. Buying a hinge, if one was even available, cost cash plus transportation. For a rancher with more time than money, the choice was obvious. Even accounting for the labor, forging was often cheaper. A cowboy earning $30 a month could spend 3 hours making a hinge that would cost $2 to buy, assuming it was available. 3 hours of labor was worth far less than $2 in cash. But there were hidden costs. Fuel, whether coal, charcoal, or wood, took time to acquire or make. Tools wore out. Hammers cracked. Tongs bent. Anvils, even improvised ones, eventually failed. And not every attempt succeeded. A poorly forged hinge might break after a month, requiring the work to be done again. Failed welds, cracked metal, and burned pieces represented wasted time and materials. The engineering that emerged from these constraints was often innovative. Ranchers adapted designs to fit available materials. A standard factory hinge might use specific dimensions and screw placements. A hand-forged hinge was custom-fit to the door and the available scrap. This led to creative solutions. A rancher might combine a hinge and latch into a single piece to save material. Another might design a gate that required fewer fittings by using wooden pins instead of metal where possible. Some frontier designs were arguably better than factory equivalents. A hand-forged hinge, made from thick wagon rim iron, could be far more durable than a thin factory hinge designed to minimize material costs. A custom latch, shaped to fit a specific gate, might work more smoothly than a generic store-bought version. The trade-off was time. Making custom fittings was slow, but for a rancher with time and scrap, it was the practical choice. By the mid-1880s, the situation began to change. Railroad expansion accelerated. More towns appeared along the rail lines. Freight costs dropped as competition increased. Mail-order catalogs, particularly Sears, Roebuck and Company in Montgomery Ward, revolutionized rural commerce. A rancher could flip through a catalog, order exactly what he needed, and have it delivered by rail and wagon freight within weeks. Prices dropped as mass production became more efficient. The transition was gradual. Older ranchers, accustomed to forging their own fittings, continued doing so out of habit and pride. Younger ranchers, growing up in a more connected West, were more likely to buy hardware. By the 1890s, most ranchers could obtain nails, hinges, and basic fittings without excessive cost or delay. Forging became less about necessity and more about preference. But the skills didn't disappear immediately. Ranchers still kept forges for tool repair and custom work. A broken plow blade still needed fixing. A specialized bracket for a new piece of equipment might not be available in a catalog. Blacksmithing shifted from survival skill to useful trade. Some cowboys became professional blacksmiths, setting up shops in growing towns. Others kept the skills. If you found this story fascinating, subscribe to the channel for more untold history from the American frontier. Hit the like button and drop a comment telling us what surprised you most about how cowboys actually built the Old West. Your support helps us keep bringing these forgotten stories to light.